So let us start our discussion. Today we are going to see another unsupervised machine learning topic. Which is called as a recommendation system for us. So far we have been discussing some concepts under unsupervised machine learning like clustering, association rules. We have discussed. And today we are seeing the recommendation system for us. So what exactly do we mean by recommendation system? What are the topics that we are going to discuss? Let us try to understand. So first we are going to look at a concept called as collaborative filtering. What exactly do we mean by collaborative filtering concept? We'll try to understand. And then we are going to discuss two types of recommendation systems for us. One is a user-based collaborative filtering concept, UBCF. And another one, what we are going to discuss is item-based collaborative filtering concept. So two things we are going to see. So one by one, we are going to discuss what are these concepts. And then we'll try to understand what are the challenges what we can face when we are developing our recommendation systems. What are some potential difficulties what we can have when we are working on your recommendation systems? That is what we are going to study. Now, the first thing what we are going to see is collaborative filtering concept. What do you mean by collaborative filtering? Let us try to understand. If person A has the same opinion as person B on an issue, if person A and B are having same opinion on iPhone, then they are going to have the same opinion on Android. So if A has the same opinion as B on an issue, then A is more likely to have B's opinion on a different issue. So A is more likely to have the same opinion as B on a different issue, like Android for us. If A and B are having the same opinion on data science, then they may also share a same opinion on Python. So what is this collaborative filtering helping us understand? It is helping us understand and find out similar people based on their opinions. Based on their opinions, we are trying to find out the similar people. We are trying to understand who are my users who are similar to each other, who are my consumers who are similar to each other, using the concept of collaborative filtering for us. So this is the fundamental concept on which your recommendation systems are developed. Collaborative filtering concept. Identification of users who are similar based on their opinion, based on their thought process. So that is the core concept of your recommendation system. When you identify similar people in the market, what is that you can do? You can recommend products to the similar set of people. You can recommend movies to the similar set of people. You can recommend books to the similar set of people. So that is what we are going to do. So finding out our similar users is important for us. Similar people. So how can I extend this logic to understand the concept better? So customer is often defined as a p-dimensional vector of items. If you go to bharatmatrimony.com, so there you are going to create your profile. You will have your name. You are going to mention your job. You are going to mention your hobbies, family background, interests. So basic details you are going to provide. Now, based on these details, what does your bharatmatrimony.com recommendation system do? It is going to select suitable profiles for our user or for our customer, and it is going to display the information. So here the customer or the user is defined as p-dimensional vector of items. So these are all my items: name, job, hobbies, family background, interests. So you can have like this many dimensions you can have. And using our interests, using our hobbies, using the information what we have given, it is going to recommend suitable profiles. Matching profiles, it is going to recommend. So P here is the number of distinct catalog items. So these are all my catalog items what I have. Also, I can decide whether my customers or users are similar based on whether they have purchased a product or not. Suppose if two people have purchased a product iPhone, then I can understand the similarity between my two users or two customers. If two people have rated a Korean serial, something in the rain, I can understand the similarity between my customers. So based on a condition, whether they have purchased a product or they have not purchased a product, whether they have rated a movie or they have not rated a movie, whether they have watched a series or they have not watched a series, you can understand what is the similarity between our customers, or what is the similarity between our users. So based on their interests, based on their buying behavior, based on their watching behavior, based on their rating behavior, you can understand the similarity between our customers, between our users. So this is what we are interested to find out. And we are interested to find this out by using the concept of collaborative filtering. So when you discover that our users are similar, then you can recommend products. You can recommend books. You can recommend movies to both our customers. So based on their interests, based on whether a person has purchased a product, not purchased a product, you can find out the similarity, and then you can recommend those products to our customers. If two people are interested in studying data science, then automatically I can recommend a textbook in data science to both my customers. So this is the idea what we are going to use. So the first thing what we have to understand is we have to study the interests of my different users. I have user 1, user 2, user 3, user 4, and so on, user n. I have all my users. Now, on my rows, I have all my users. Person 1, person 2, person 3, person n. On my columns, I have my items. Item 1, item 2. These items can be anything. They can be books, they can be movies, they can be articles, they can be products. You can have anything as your items. Now, this matrix is called as user item interaction matrix. This matrix is called as user item interaction matrix first. So if you look at the information here, person 1 has not given us any information about item 1. He has given some information about item 2. Similarly, he has not given us any information about item P and other items. Person 2, he has given us information about item 1. He has not given us information about other items for us. Person N, he has not given us information about item 1, item 2, but he has given us information about item P. So we have to work on this user item interaction matrix. We have to use this information and we have to find out our similar users, or we have to find out similar personalities from this data. That is what is the objective. Now, how can we expand on this user item interaction matrix? How can we throw more light on this user item interaction matrix? Our users can be subscribers, they can be our readers, they can be our buyers. They can be subscribers, they can be buyers or readers, consumers. And our items, they can be movies, they can be articles, they can be products, they can be books. And then to study the interest of our users, to study the buying behavior of our users or customers, you are supposed to create this user item interaction matrix. So the values in my user item interaction matrix can be rating given by user to a movie. I can have my different ratings given by a user for a different set of movies. Or the values can be time spent by a reader on an article. How many minutes he has spent. Has he taken longer time to read? Has he taken shorter time to read a particular article? You can write down how many minutes he has spent. Or we can have values like whether a person has clicked on a product or not when the product was presented to him on a screen. So whether a customer clicked on that product or not. You can have that kind of information also as values in your user item interaction matrix. So our job is to create this user item interaction matrix when we are presented with data. This is what we are supposed to do. Now, suppose I give you an example. What is that example is? You have different set of users here. User 1, user 2, user 3, and so on, user n. A different set of users are there. And then we have our movies. Movie 1, movie 2, and so on, movie P as our column names. So what is the information that we have in our user item interaction matrix? We have information about the rating provided by different users for different movies. So user 1 has given a rating of 3 for movie 1. User 1 has given a rating of 4 for movie 2. And he has not given us rating for all the other movies in our data. Similarly, user 2, he has given a rating of 2 for movie 1. He has not given a rating for all the other movies. Similarly, user n, he has given a rating of 5 for movie 1. He has given a rating of 1 for movie 2. And he has not given ratings for all the other movies. So this is our user item interaction matrix set. Now, the question is, whenever we are trying to compare and find out the similarity between two users, we are not supposed to use that product or item which has not been rated by any of our users. What do you mean by this? If you look at item 2 here, or movie 2, this movie 2 has not been rated by person 2. He has not given us any information. There is loss of information here. We don't know. Then you are not supposed to use movie 2's rating for comparing the similarity between our two users, person 1 and person 2, because we don't have this information. When you don't have the information, you are not supposed to use that movie for finding out the similarity between our two users. So keep this concept at the back of your mind. Item 2 or movie 2 cannot be used. So how do you overcome this potential loss of information? So simply transform your data into a binary matrix first. Transform your data into a binary matrix. So we have our users on our rows. We have our users. And then we have our items, movie 1, movie 2, movie 3, movie 4 we have. Now what I'm going to do is, if I simply transform my data into ones and zeros, what is going to happen? Let us try to understand. So person 1 has rated movie 1. So I'm going to assign a value of 1. So whenever a person is rating a movie, I'm going to assign a value of 1. So we have 1 here. Now person 1 again has rated movie 2. So assign a value of 1. What about movie 3 and movie 4? Person 1 has not rated movie 3 and movie 4. Okay. So my first row, I have converted into ones and zeros based on whether that person is rating a movie or he is not rating that movie. What about person 2? Person 2 has rated movie 1. So assign a value of 1. Person 2 has not rated movie 2. Assign a value of 0. Person 2 has not rated movie 3 and movie 4. Assign a value of 0. So now you have converted your user item interaction matrix into a binary matrix. So we have done this. So how is this going to help us? We have to understand. So now, based on this ones and zeros, based on my binary matrix, now, how is it going to help us? Because you have transformed your data into ones and zeros based on the logic of whether the person has rated the movie or not rated the movie. I can use now my movie 2's rating for finding out the similarity between our two users. Now there is no loss of information, and therefore I can use my binary matrix for finding out the similarity between our users, user 1 and user 2, or person 1 and person 2. So information on the rating matrix along with the information on whether the items were rated or not. So I can use my user item interaction matrix. I can use this piece of information which is there in my user item interaction matrix, and also I can use the information what I got from my binary matrix, and I can find out the similarity between my users. So instead of working on only our user item interaction matrix, you can also take the help of your binary matrix, and then you can develop the similarity between our users. And we can build our recommendation system using the information. So that is the idea. So both of them can help us, can be better than simply working on your user item interaction matrix only. So more the information that we have, the better it is for us. Now, how can we calculate our similarity? That is the next question. We know we have to find out our similar users, but to find out our similar users, we have to calculate our similarity. So what is the concept that we are going to use? What are the concepts that we have already discussed in the past? And are there any new concepts which can help us calculate our similarity? We'll try to understand. That is what we are going to find out. So let us see one by one. What are the different methods that you can use for calculating your similarity? So first method that we can use is called as cosine based similarity for us. So what is the first method? It is called as cosine based similarity first. So what is the formula? Cos of a comma b is equal to a dot b divided by modulus of a into modulus of b first. So a and b they are our two users, a and b. Now these are my different movies, movie 1, movie 2, movie 3, movie 4. So these are the ratings provided by our users, A and B. Now apply our formula. So A1, A2, these are the ratings provided by user A. B1, B2 are the ratings provided by user B first. Then take the dot product, A dot B. A1, B1 plus A2, B2 and so on A and Bn. So find out the dot product for our two users. 3 into 1 plus 5 into 4 plus 0 into 0 plus 1 into 0 for us. This is the dot product. Now you have A dot B. This is ready for you. Then what you are going to do, divide it by modulus of A into modulus of B. How can you find out modulus of A into modulus of B? Modulus of A is nothing but root of A1 square plus A2 square plus AN square. Root of 3 square plus 5 square plus 0 square plus 1 square. This is modulus of A. Multiplied by modulus of B. What is B? Root of B1 square plus B2 square. This is modulus of B. The root of 1 square plus 4 square plus 0 square plus 0 square. So when you solve for this, cos of A comma B, what is the answer that you are getting? So when we solve for this, cos of A comma B, using the formula, we are going to get 0.94. This is the answer what we are getting, 0.94. Now, cos of A comma B, if this value is 0.94 for us, then what can you say is the angle between A comma B? This value is closer to 1. Now, cos 0 is 1. This all of us know. Cos 0 value is 1. So angle between A and B is 0 for us. So when angle between A and B is 0, then what can you say about A and B? They are going to lie on the same straight line. There are 2 points on the same straight line first. Angle between A and B is 0 first. So what can you say? When the angle between A and B is 0, you can say that our A and B are similar users first. You can conclude that A and B are similar users. That is what you are going to do. Now, what if you get cos of A comma B is equal to 0 for us? What is A comma B? Angle between A comma B. It is 90 degrees. Cos 90 is 0. Then what is the angle between A and B? 90 degrees V. Then what is that we can say about A and B? A and B are our different users. They are dissimilar users. That is what we can comment on A and B. So this is one of the methods, one of the metrics that you can use when you are trying to find out the similarity between our users or persons. How are you going to program this logic in Python? Simply you can say metric is equal to cosine. And then in the background, it is going to apply our cosine based similarity calculations, and it will give you the similarity between our users. Metric is equal to cosine. It is the first method, which is new to us. What are the old methods that all of us are already familiar with? Correlation concept. Finding out the similarity between correlation. What do you mean by correlation? Correlation between two users A and B can be calculated using our formula. What is our formula? Covariance A comma B divided by standard deviation of A into standard deviation of B. So when you standardize your covariance, you are going to get your correlation first. That is the logic. So this is the manual formula for calculating your correlation. Now, if the correlation between my user A and user B is 1, then what can I say? I can say A and B are identical users. I can say A and B are similar users. So no need of any manual calculations. Just you can say metric is equal to correlation. If you say, more than enough. In the background, it will apply your correlation based methodology and it will find out the correlation between our users. It is going to do that. So any method you can use. Cosine based similarity you can use. Correlation based similarity methods you can use. What are the other methods? What we are already aware of. Let us try to understand. We're going to come back to these other slides what we have. But first, let us try to study what are the other methods. We can use the concept of nearest neighbor. So you can use the concept of K nearest neighbor. There is a separate concept altogether. We are going to discuss that in our coming sessions, where I'll be explaining you how you can use your K nearest neighbor concept and find out the similarity between our users. That is another method what you can use, nearest neighbor concept. What are the other distance measures that you can also use to find out who are your neighbors? You can use the concept of Euclidean distance. What is the formula of Euclidean distance? root of y2 minus y1 whole square plus x2 minus x1 whole square. So here you can simply calculate your Euclidean distance, 3 minus 1 whole square plus 5 minus 4 whole square and so on. So using the logic of Euclidean distance also, we can find out the distance between our users. You can do that. You can identify your neighbors. Then you can also use the concept of Manhattan distance first. So instead of taking the square root, simply take the modulus between the rating values provided by our two users. So this can also be applied for finding out the distance between our users, identifying who are our neighbors. So all these methods you can use for finding out your similar customers, your similar users. So all these methods are available for us. So remember all these techniques, what we have discussed. Then what is the information that we are supposed to keep in mind? While computing the similarity between person 1 and person 2, or while computing the similarity between user 1 and user 2, item 2's rating cannot be included first, because person 2 has not purchased that item, or person 2 has not rated that item. Person 2 has not rated that item first. Therefore, you are not supposed to use this item 2. So how can you overcome this potential loss of information that you have? You can simply transform your data into a binary matrix. So assign a value of 1 if the person has rated that movie or purchased that product. Assign a value of 0 if that person has not purchased the product, not rated that movie. Then we will be in a position to overcome this challenge. We will be in a position to overcome this challenge first. So this is what you have to understand. So this is an important point, what you have to remember. Now, what more you can do before we find out the similarity between our users? We can also normalize our ratings. Suppose if there is a very famous movie for us. Now all the users would have watched that movie, and you can expect that they are going to give a very high rating for that movie. So my users have given a very high rating for that movie. Now what is going to happen? This high rating for this movie is going to affect your distance calculations. And therefore it is going to affect our similarity between our users or customers. So this movie is going to impact our distance calculations, similarity calculations between our users. between our customers. So what you can do, normalize these values, neutralize these values, reduce the impact of these values. That is what we are going to do. How can you reduce the impact? Multiply the vector components by inverse frequency. So this is a vector for us. User 1 is a vector, and this is a vector component, phi. So multiply the vector component by inverse frequency. What do you mean by inverse frequency? It is the inverse of the number of customers who have purchased or rated the item. So it is the inverse of how many users have given that rating for that movie. So 5 into 1 by 4. What is the answer? 1.25. So now instead of 5, you can normalize the rating value to 1.25. User 1, user 2, user 3, user 4. And you can use these normalized values and then find out the distance between our users. Same concept we have done in case of our clustering also, if you remember. Before finding out our distance, we have normalized our data points. And then we were able to find out the distance between our observations. So the same thing you can do here. Because there, what was the problem? We were dealing with our semester fees, which was in thousands of dollars. So because of this scale problem that you had in our data set, you had to normalize this value. And then when you were normalizing that value, you were able to easily find out the distance between our observations and interpret that distance. We were able to interpret that distance for us. That is the logic. So same thing here also you can do. Normalizing of our ratings. Now, once we have discovered they are similar, once you have identified your similar users, what items are you going to recommend? That is the next question. So imagine you have performed these background calculations and all, and you have discovered your similar users. Now, what is the strategy that you are going to use to recommend items to these users? Obviously, you are going to recommend that item which has not been purchased by the user. So obviously, we are going to recommend that product which has not been purchased by the user. So what you can do, you can create a list of multiple items. I1, I2, I3, I4. You can create a list of multiple items like this. And you can apply our strategy. What kind of strategy you are going to apply? For example, you can rank all the items according to how many similar customers have purchased that item. So I1 is the item that has been purchased by maximum number of similar users. I2 is the item which has been purchased by the second highest number of similar users. I3 is the item which has been purchased by the third highest number of users. So based on how many similar customers have purchased that product, you are going to rank your items in that order and you can recommend to our users. So this is one strategy what you can use. What is another strategy? Based on which item has been rated by most number of customers. Item 1 has been rated by maximum number of customers. Item 2 has been rated by second maximum number of customers. Item 3 has been rated by third maximum number of customers. Item 4 has been rated by fourth maximum number of customers. So in this order, I can recommend my products to my users. So this is another strategy I can use. Rated by most number of customers. Or I can use another strategy. Based on the highest rating, I can rank my multiple list of items. Item 1 has received the highest rating. Item 2 has received the second highest rating. Item 3 has received the third highest rating. Item 4 has received the fourth highest rating. So I can rank them in the descending order of their rating. And I can recommend my products to our users. So this can be another strategy based on highest rating provided by our customers. Now, what can be another strategy for us? Based on some popular criteria. So suppose if our movies have won Oscar awards. So based on the number of Oscar awards that movie has won, whichever movie has received highest number of Oscar awards, first I'll recommend that movie. Whichever movie has won second highest number of Oscar awards, recommend that movie. Third, whichever movie has received third highest number of Oscar awards, recommend that movie. Fourth, whichever movie has received fourth highest number of Oscar awards. So I can recommend in this order based on popularity. Popular choice. So like this, these are different strategies that you can use for recommending your items to our users, our customers, our consumers. So beyond this also, you can develop any of your own strategies and then you can also recommend your list of items to our users. You can also do that. So now remember all the concepts what we have discussed, right from collaborative filtering to our user item interaction matrix. Then what are the different methods of finding out the similarity, cosine based, correlation based, all these concepts you remember. And then how can we normalize our ratings? And finally, how can we develop our strategies for recommending our items to users? So all these concepts, you write them down. So next, going forward, we are going to discuss what are the challenges that you may face when you are developing our recommendation system. And also, how can you overcome these challenges? What are the possible solutions where you can overcome these challenges? that we are going to see. And also we are going to discuss what are the potential features that you can come across when you are working on your recommendation systems. All these things we are going to discuss, and then we are also going to talk about item-based collaborative filtering. So far, we have been discussing user-based collaborative filtering, but we are going to focus on item-based collaborative filtering. So take a break now for 10 minutes, and then after the break, we are going to discuss our remaining topics. So take a break and come back. So let us continue our discussion. What are the potential negatives that you are going to observe when you are working on your recommendation systems? So first negative or first drawback that you are going to see is most of your recommendation systems are memory based. That means they by heart the values which are present in your data set. They tend to memorize, they tend to remember. So because of which, what is a challenge that you're going to face is when you slightly change your observations in your data set, this recommendation system will find it difficult to adapt, to learn from the new set of observations that you have in your database, and then it becomes difficult for the recommendation system to replicate the same performance on this new set of observations which are present in your data set. So replication is a problem. Replicating the same performance on new information that we have introduced in our data set becomes a challenge. So these recommendation systems are lazy learners. So they take some time to adapt themselves to the changing environment and then try to understand the observations which are there in your data set. So replication is a problem. Next, what is the second disadvantage? What you are going to have? When you are working on more number of users, and also if you're trying to understand the buying behavior or the rating behavior of more number of users on larger data sets where you have more number of items, where you have more number of products. So what is the challenge that you're going to face? The challenge what we are going to face is it becomes computationally difficult for us, computationally intensive for us, computationally expensive for us to build recommendation systems on this large data what we have. So if you are trying to build a recommendation system for Amazon, then Amazon may have 1 million customers, for example, and it may sell 2 million products on its website. Then it becomes even more challenging for us to understand all the permutations and combinations of our users and our items, and then develop a recommendation system on this large data set. So that is the second most challenging aspect what you are going to face when you're working on recommendation systems. So how do you overcome this challenge? How do you overcome this computational intensive challenge that you are facing when you're developing your recommendation systems? So what are the possible solutions which can help us in reducing the computational requirement? So there are a couple of solutions what we have discovered. So the first solution can be, you can randomly sample your customers. You can randomly sample our customers. And then for these sampled customers, you can start understanding the buying behavior and then find out the similarity between our sampled customers and start recommending our products to these sample set of customers. So instead of working the entire user database, you can collect samples. So this is one possible solution, which will require for us to select samples from our user database. So this can help us reduce the computational requirement. What is the another solution that you can have? We can discard infrequent buyers. So buyers who are purchasing a product maybe twice in 1 year or thrice in 1 year. These are infrequent buyers for us. So what you can do, you can simply discard those users or buyers or customers from our user item interaction matrix. And then you can also reduce the computational requirement. You don't have to worry about those kind of buyers or customers. What is the other solution? You can discard items that are very popular or very unpopular. So items which are very popular, anyways, people are going to purchase, even if you're not going to recommend those items, because they're very popular. So customers are obviously going to purchase these kind of products or items. What about unpopular items? The customers are anyways going to purchase these kind of unpopular items because they are very unpopular. They're not going to purchase. So what you can do, you can discard these very popular items. You can discard our very unpopular items from our data set. So number of items you can always cut down using the logic of popularity and unpopularity. You can cut down your items. What is the another solution that we have that you can use? You can apply the concept of clustering. So if you can cluster your customers, if you can group your customers together, and then potentially it is going to help us in reducing the number of rows. I can form my clusters and I can reduce the number of rows for which I have to compute my recommendations. So clustering can be one concept that you can apply on your data set, which can help us reduce your computational requirement. Form clusters on your customers and you can recommend your products or items to these cluster members. You can do that. What is the another solution? PCA, Principal Component Analysis. So what is this concept telling us? This concept is capable of reducing the number of columns that you have in your data set without losing information. So principal component analysis is a technique. It is a data analysis technique which is available for us, which is capable of reducing the number of dimensions or columns that you have in your data set without losing any information. So for example, if I have 30 dimensions in my data set, if I want to reduce 30 dimensions to maybe 2 dimensions, I can do this with the help of principal component analysis. So what is the advantage that I'm having? I can work with lesser number of columns. So initially I had 30 columns, but now I can work only with 2 columns. At the same time, these 2 columns are going to have all the information, almost all of the information which is required for your analysis. So when you apply this principal component analysis concept on your data set, you will be in a position to reduce the number of columns. So therefore, when you reduce the columns or dimensions, automatically you are reducing the computational requirement. You are reducing the computational intensity of this problem. And it is going to help you in building your recommendation engine on this data set for us. So you can either reduce your rows or you can reduce your columns. Try to lessen the complexity which is involved in computation, and then you can develop your recommendation systems. So these are possible solutions which are available for us, using which you can overcome some of the challenges when you are working on your recommendation systems. Now, what are the common features that you are going to observe? What are the common attributes that you often observe when you are working with your recommendation systems? One common attribute is there will always be a trade-off between your runtime and quality of recommendation. There will always be a trade-off. What do you mean by trade-off? So if your runtime is very high, then the recommendation system is taking more time for recommending your products. So one such example is, if you go to bookings.com website, and then if I want to happen to go to Pondicherry, now I'm mentioning my requirements. What are my requirements? My budget is 2,500 to 3,000 per night. And I want the room to be sea facing. I want complimentary breakfast. I want the room to be located in White Town. I want the room to be located near Rock Beach. So these are all my recommendations. So what does your website do? It is going to try to process all the information. It is going to understand what are your requirements, and then it is going to give you a recommendation which is going to match your requirements. It is going to suggest you a hotel or a room which can satisfy your requirements, which can fulfill your requirements. So what is happening? Slightly, the computational time to understand your request is going to be slightly more. At the same time, you can ensure that the quality of the recommendation to be very high. You can ensure that the quality of the recommendation coming from that recommendation engine to be very high, which is going to satisfy all the requirements. But what about the other recommendation systems? Like for example, if you are working on a recommendation system developed by a supermarket or an online grocery store, what may happen? If I'm looking for a product like Aveeno baby cream, that product may not be available in my online grocery store. Then what is it going to do? It is going to recommend alternate products. It is not going to give me the exact product as a recommendation, but it is going to give me some alternate products which are very close to Aveeno baby cream. So what is happening here? The processing time taken by these kind of recommendation systems is very less. So while the customer is browsing for that product, the online grocery store is automatically going to recommend the products to us. So the processing time taken by your online grocery store recommendation system can be very less for us. But at the same time, the quality of your recommendation may not be very high. You may not find the products what you're actually looking for. So if I'm looking for a product, I may not actually find that product. For example, if I'm looking for a product like Slurp Farm biscuits, I may not actually find these kind of biscuits in my recommendations. It is going to give me an alternative. So what is the feature of this kind of recommendation system? The runtime taken by the recommendation system is very less, but at the same time, the quality of recommendation is not that high. So there is always a trade-off between your runtime and quality of recommendation. So some recommendation systems are going to recommend better results, but the time taken by them to process or understand the requirements is slightly going to be high for us. So this is what you have to understand, the trade-off between your runtime and quality of recommendations for us. So keep these concepts at the back of our mind. These are going to help us understand the behavior of different recommendation systems. Now, so far we have been talking about a user-based collaborative filtering concept, where we were discussing similar users, where we were trying to find out our similar set of users. That is what the focus was, using the concept of collaborative filtering. But now we are slowly going to move towards your item-based collaborative filtering, trying to find out similar items. So items can be anything. Items can be a person, items can be a product, items can be a book, items can be a movie title, items can be anything. So whenever you display what is the item that you're looking for in your search window, in your search bar, automatically you are going to see all the items which are very similar to what we are looking for. So for example, if you do this in Google, if you type the name of the person Abdul Kalam, then what is going to happen? You're going to get a list of people who are very similar to Abdul Kalam. You may get the list of presidents who have served our country. So it is going to display all the people in the results. So people also searched for. So if you look for movies directed by Christopher Nolan, then automatically it is going to give you the list of all the movies which are directed by Christopher Nolan. It is going to give you the display of all the DVD titles, movie titles of the same director. If you look for books written by J.K. Rowling, then what is going to happen? It is going to recommend similar kind of books, similar items written by the same author. So based on the item, you are able to find out what is the list of items which are similar to what we are looking for. That is the concept of item-based collaborative filter. So what is that you are going to do? Now, it is that time of the day where the attendance link has been circulated. So take some time and fill in your details for today's session. So fill in all the required details mentioned in the attendance form without forgetting, because it is important for us. So that is the first priority. Try to fill in your attendance form using your details. And then you can always come back and listen to our discussion. So now we are slowly going to move towards understanding the concept of item-based collaborative filter, IBCF. Item-based collaborative filtering. So here our objective is to find out what are those items which are related to each other. So you can use the same methods what we have discussed in our user-based collaborative filtering concept. You can use your cosine methodology to find out the similarity between our items. You can use our correlation methodology also to find out the similarity between our items. But what is the only difference in your item-based collaborative filtering? Items are vectors. So items are vectors. So these are my items. Item 1, item 2, item 3, item 4, item 5. And users are nothing but components of this vector. So customers are components of your vector. So items are going to be on your rows and users are going to be on your columns. So this is how you can define your item user interaction matrix. This is how we can define item user interaction matrix for us. So again, based on the values, you can find out the similarity between our items. We can find out. But what is the one thing that we have to remember before we are finding out the similarity between our items? You have to make sure that users or customers have rated both our items, I1 and I2. Only if my customers have rated both the items, then I can consider those data points for finding out the similarity between my items. If any of the user has not rated our items, then you cannot use that data point for finding out the similarity. You cannot use that value for calculating our similarity between items. It is the same concept what we have discussed in case of a user-based collaborative filtering for us. It is the same concept. There is absolutely no change. So that is what you have to understand. So we are going to see this. So you have your item user interaction matrix. So your items are on our rows and our users or persons are in your columns. So item 1 has been given a rating of 3 by person 1. Person 2 has given the rating as 2 and person n has given the rating of 5. Similarly, person 1 has given the rating of 4 to item 2. He has not rated item 2. And then person n has given a rating of 1 to item 2. So you can use our cosine based similarity. You can use a dot b modulus of a into modulus of b to find out the similarity between your items. Or you can use our correlation based similarity formula you can use. But what is the important thing that we have to remember? We have to remember that while computing the similarity between our items 1 and 2, we cannot include person 2's rating because person 2 has not rated that item 2 or he has not purchased that item 2. So how you can overcome this loss of information? Convert this matrix into a binary matrix first. So convert it. So what is going to happen? You can simply convert this matrix into ones and zeros first. So when you do this, then potentially you have overcome this loss of information what you had initially. And then you can use our binary matrix and then you can include person 2 when you're trying to find out the similarity between item 1 and item 2. So person 2's rating can be included because you have transformed your data into ones and zeros into your binary matrix. That is what you have done. So that is what you have to understand. Now, what are the critical limitations that you are going to face when you are working on your collaborative filtering concept? What are the critical limitations, critical shortcomings of collaborative filtering concept? The critical shortcoming is cold start. What do you mean by cold start? How to create recommendations for new users. If you have new users in the system, how are you going to create your recommendations for those new users? That is a problem, what you are going to fix. Then, what is the second critical shortcoming? How about new items? How are you going to sell your new items which are not going to have any correlation? You cannot find any similarity between your new items and old items. So how are you going to sell these products? How are you going to market these products? That is the question. So what you are going to do? Some solutions we have that you can apply in order to overcome your critical shortcomings. So there are some solutions for us. So how do you overcome the problem of cold start with new users, what you can do is you can start recommending the list of popular items to our new users, and you can get a quick reaction from the user. You can do this as the first step. What is the second step? We can demographically also recommend relevant items based on their age profile, based on their region, based on their language. You can recommend demographically relevant items to those kind of users, new users. Also, you can take a look at their browsing history, and then you can also recommend. Based on their interests, based on their choices, you can recommend your items or products to new users. You can do that. Also, you can take a look at the secondary source of information. You can take a look at their social network, what kind of subscriptions they have, and then based on that, you can recommend your products. So these are available options that you have that you can make use of when it comes to recommending your products to new users. This is what you can do. So if there's any new user on Netflix, then you can invite them to start rating some movies. So when you invite them to start rating some movies, then you can collect the information. What are their interests? What kind of movies they watch? And then using that information, you can recommend the list of items to our new users. So all these are multiple ways in which you can overcome the problem of cold start with new users. So these are some methods. Now, how are you going to overcome the problem of cold start with new items? What is the solution that we have? You can recommend this list of new items to random users. Okay, just select some random users in your profile, in your Facebook profile or in your Twitter, in your friend circle, in your communities, in your groups. Just select some random people, and then you can offer these new items to these random users, and you can collect some feedback. You can understand, you can find out what is their experience of this new item, what is their experience of this new product. Are they trying to compare it with any other product? Then automatically you can understand and estimate what kind of correlation does your new item has with the existing product, and you can target your customers with these new items. So this is how you are supposed to develop your strategy, how you can overcome the potential problem of cold start with new items. How about offering the product to influential people? In LinkedIn, you have influential people, network is there, influencers are there. Then what you can do, you can sell these new items to the influencing community on LinkedIn. And then you can ask them to share the information about the product on their profile. And you can find out what kind of traction your new item is having in their profiles. And you can understand what kind of customers are getting attracted towards your new item. That is how you can find out, understand what is the prospect of your new item. And you can start selling these new items on your social media platforms. That is what you're supposed to do. So this is all the theory that we have related to our concept of recommendation system. So this is the theory what we are having. Now, how can you apply this concept in Python? Let us try to understand. So first, let us look at our UBCF, user-based collaborative filtering concept. So import your libraries, pandas, numpy, basic libraries, and read your file, movie 1.csv. This is the name of the file that we have. So let us try to understand what is the data that we have. Movie 1. So this is the data set that we have. We have user ID. So different users I have 3, 6, 8, 10, 11. All these are different users in my data set. I have movies, Toy Story. And then if I scroll down, I have different movies like Jumanji, Grumpier Old Men, Waiting to Exile, Father of the Bride 2, Heat, Sabrina, Sudden Death, GoldenEye. All these movies I have. And the last column is a rating column. These are the ratings provided by different users. So one user can provide rating for multiple movies. It is possible for us. So you have around 10 movies and you have a list of users. User ID 3, 6, 8. These are all bunch of different users what we have in our data set. So now read your file. Then take a look at your data set. So you have around 8,992 rows and 3 columns here. So you can get a overview of your data set. How many observations you have, how many columns you have. Now take a snapshot of top 5 rows. These are the top 5 rows that you have in your data set. So user ID 3, 6, 8, 10, 11. All of them have given their rating for Toy Stories. This is the rating what they've given. And they've also given their information. So user ID 3 has rated Toy Story as 4. User ID 6 has given 5 for Toy Story. Like this, they've given their rating. Now, if you want to find out the number of unique users in your data, so simply use our unique function and find out how many unique users are there. What is the length? So you have 4,081 unique users. They're having unique user IDs in your data set. So this is the information what we have. Now, what is the list of unique movies that you have in your data set? How many unique movies we have? We have 10 unique movies in our data set. Toy Story, Jumanji, Grumpier Old Men, all these are, if you total them, you are going to get 10 unique movies are there in our data set. Waiting to Exhale, GoldenEye and all. Now, let us try to create our user item interaction matrix. So we're going to take the help of our pivot function. Pivot table you can create. An index for my pivot table is going to be user ID. This is my index. I'm going to have my user ID here. And then columns. My column names are going to be my different movie names that I have. Father of the Bride 2, GoldenEye, Grumpier Old Men, Heat, Jumanji, Sabrina, Sudden Death, Tom and Huck, Toy Story, Waiting to Exhale. All these I'm going to have as my movie names in my columns. Then values. I'm going to have my rating values. So this is what I have as my information. This is the information what I have. So you have some null values in your data set. So we are going to handle your null values in few minutes. And then you're resetting the index. Resetting means you're rearranging your row numbers. You're dropping the original index. So drop off the original index. And this is the new index what we have for the pivot table what we have created. So now, if you look at my user item interaction matrix, on my rows, I'm supposed to have my user ID. I should have my users on my rows. So what I'm going to do, I'm simply going to replace my index values with my unique user ID values. I'm going to replace my index values with my unique user ID values on my rows. So now I've replaced my index values with unique user ID values 3, 6, 8, 10, 11, and all of them my unique users. So this is my user item interaction matrix that I have. Now what I can do, I can simply replace my null values with 0 values. I'm going to replace my nan values or null values with 0. So fill NA is a function which is going to fill your null values with 0. So it is filling all your null values with 0 that we have. So this is what we have done. Now, what is the next step? Calculate the cosine similarity between our users. So from ExcelR.metrics import pairwise underscore distances. This is the function what we are going to use, pairwise underscore distances. So apply your pairwise underscore distances on your user item interaction matrix, and metric is equal to cosine. I told you can simply say metric is equal to cosine, and in the background it is going to apply our cosine methodology. Now why are we saying 1 minus here pairwise underscore distances? Understand this logic. If I am 80% dissimilar to my brother in terms of features, then I must be 20% similar to my brother in terms of my features. So if I'm 80% different from my brother in terms of my facial features, then I must be 20% similar to my brother in terms of my facial features. So that is why you're doing 1 minus pairwise underscore distance. This is going to give you your similarity between our different users. 1 minus pairwise underscore distances. So apply that. Now I get my user similarity scores. So I have 1, 0, 0, 0 point something, all these values I have. I can convert this user similarity data that I got into a data frame. I can store the results in a data frame. So store our similarity scores between our users in a data frame for us. Store the results in a data frame. Now, for this data frame, I'm going to provide my row names and column names. So I'm going to provide my row names and column names for my data frame that I've created. What are the row names I'm going to provide? User IDs. What are the column names that I'm going to provide for this data frame? Also user IDs. So we are going to set our index and column names to user IDs for our data frame that we have created. So setting the index, setting the column names as my unique user ID values. So we have set our index to our unique user IDs, and we have also set our columns to our unique user IDs. Now, what is that we can understand from this matrix that you're seeing here? All your diagonal elements are 1. That means my 3 and 3 are identical users. 6 and 6 are identical users because the cosine value is 1. 8 and 8 are identical users. So this is the information what I got. But even a small baby can tell me that 3 and 3 are similar, 6 and 6 are similar, 8 and 8 are similar. So there is no information from finding out that 3 and 3 are identical users. So what I'm going to do, I'm going to convert all these values. I'm going to transform all my values in my diagonal to zeros because they are not adding any value for my similarity. So fill all my elements in my diagonal, fill underscore diagonal with 0 values. So now all the values in my right diagonal have been converted into zeros. Now observe what we are going to do. If you look at 3 and 11, the cosine similarity between 3 and 11 is 1 for us. So what is that you can understand from this? 3 and 11 are identical users. This is high quality information for us. I can use it in my analysis because I've discovered that they are identical users for us, 3 and 11. Similarly, I have discovered that 6 and 168 are also identical users. 8 and 16 are also identical users. So what I can do, this is high quality information, what I'm going to apply. So let us take the example of 6 and 168. So you have user ID 6, user ID 168. So find out what are the movies that user ID 6 is watching, user ID 168 is watching. 6 is watching Toy Story, Grumpier Old Men, and Sabrina. So what you can do, because 6 and 168 are similar, I can recommend all the movies which are not watched by user ID 168 and which are watched by user ID 6. So 6 is watching Grumpier Old Man and Sabrina. So I can recommend these two movies to my user ID 160. So because they are similar users with similar interests. So I'm going to recommend these movies. That is the logic. This is the concept of user-based collaborative filtering for us. Now come down. Let us apply item-based collaborative filtering. So I'm selecting one movie, Sabrina. I'm just trying to find out what are the ratings given by my unique user IDs for my movie Sabrina. Find out what are the movies which are correlated with my movie Sabrina. So these are all the correlation that I have with my Sabrina movie. So you can find out Father of the Bride 2 is having a correlation of 0.28. GoldenEye is having a correlation of 0.02. Like this, you have correlation with our movie Sabrina. So now, create a data frame for all the movies which are similar to Sabrina and name that column as correlation. So these are all the movies which are correlated with Sabrina in a data frame for us. Now, I'm only interested in finding out movies which are having a correlation value of greater than 0. So focus on those movies which are having a strong positive correlation with your Sabrina and sort all your values in descending order of correlation. So now, what are the movies that you can recommend? You can recommend the Father of the Bride 2, which is close to your Sabrina. Next movie which is close to your Sabrina is Grumpier Old Men, Waiting to Exhale, and Sudden Death. So this is the manner in which you can recommend your similar items which are related to your Sabrina movie. That is the idea. So this is the concept of our recommendation systems. So with that, we can break for the day here. And tomorrow, we are not going to have our lecture. Your next lecture or next class is going to be on Monday. So till then, try to revise all the concepts that we have discussed in class over the week. And then I'm going to connect back with you same time on Monday for our next discussion. Till then, take care, stay safe, and thank you very much for your time today. See you all on Monday. Bye.